welcome to today's class. Today we shall deal with ionic equilibrium. In ionic equilibrium, the important topics are ionic equilibrium. In ionic equilibrium, the important topics are acid-base theories, acid-base theories. What are the acid-base theories? We have Bronsted theory and Lewis theory. So we can expect theoretical questions from the Bronsted theory and the Lewis acid theory also. Now next topic is ionic product of water. Ionic product. Next pH scale and numericals on pH scale. Next buffer solutions and salt hydrolysis, and solubility product. These are the important topics in this chapter, solubility product. Now coming to the ionic product, what are the important points regarding the ionic product? At 25 degrees centigrade, ionic product value Kw is equal to 1 into 10 to the power of minus 14 mole square by liter square. Remember that the value of Kw will remain constant as long as temperature is maintained constant. In case of dilute solutions of acids and bases, H plus ion concentration is equal to Kw by OH minus ion concentration, and OH minus ion concentration is equal to Kw by H plus ion concentration. In pure water and neutral solutions, Kw value can be written as either H plus square or OH minus square, because in pure water and neutral solution, the concentrations of H plus ions and OH minus ions are equal. Now coming to the pH scale. In pH scale, what are the important points to be remembered? For strong acids, H plus ion concentration is equal to normality of the acid is equal to 10 to the power of minus pH. For strong bases, OH minus ion concentration is equal to normality of the base is equal to 10 to the power of minus pOH. In case of weak acids, H plus ion concentration is equal to C into alpha is equal to root CKa. Similarly, for weak bases, OH minus ion concentration is equal to C alpha and root CKb. And what are the other models? For in case of weak acids and bases, Ka into Kb is equal to 10 to the power of Kw. What is Ka here? Dissociation constant of the weak acid. What is Kb here? Dissociation constants of its conjugate base. The product will be equal to Kw. This is one important relation we have to remember. In case of pH scale is applicable only to the very dilute solutions. For acids of moderate concentrations, that is 1 normal and above, for strong acids of 1 normal and above concentration, pH will be equal to 0. For strong bases of 1 normal and above concentration, pOH will be equal to 0, that is pH is equal to 14. So pH scale is applicable only for very dilute solutions of acids and bases. Now in case of In case of the dilute solutions, very dilute solutions of strong acids and strong bases, pH value will be nearly equal to 7. For very dilute solutions of strong acids and strong bases, pH value will be nearly equal to 7. If it is an acid, it will be slightly less than 7. If it is a base, it is slightly greater than 7. Why it is so? For very dilute solutions of acids and bases, the ionization of the water cannot be neglected because common ion effect will be less in case of very dilute solutions. Take for example, in case of 10 power of minus 3 HCl and 10 power of minus 7 HCl, in case of 10 to power of minus 3 molar HCl, in presence of 10 to power of minus 3 molar HCl, the ionization of the water will be suppressed due to the common ion effect. Hence, H plus ions given by the water can be neglected. In case of dilute solutions like 10 to power of minus 7 molar HCl, the ionization of the water cannot be neglected because the effect of common ion is less. Here in this case of very dilute solution, the common ion effect will be less, hence the ionization of the water cannot be neglected. Here ionization of the water can be neglected because due to moderate concentrations of the acid, the common ion effect will be predominant and ionization of the water will be suppressed here. Here it cannot be suppressed. That is why for very dilute solutions of strong acids and strong bases, pH value will be nearly equal to 7. And what is the other important point? To change the pH value, by n units, H plus ion concentration should be changed by n units, 10 to the power of n units. So change in H plus ion concentration will be equal to 10 to the power of n, where n is equal to initial pH minus final pH, and one more important point is to increase the pH value by 0.3 units. To increase the pH value by 0.3 units, the volume of the solution should be doubled. This is one important tip which students are expected to remember. So, to change the pH value by n units, what should be the change in H plus ion concentration? 10 to the power of n, where n is equal to initial pH minus final pH. Now what are the other important point? So, finding the pH values of the resultant solutions, which we will do through our numericals. Next thing is buffer solutions. What is a buffer solution? Which maintains constant pH value even after the addition of small amounts of the acids and bases or on dilution. So, every buffer will have a mechanism in the form of reserve acid and reserve base, which will arrest the activity of H plus ions and OH minus ions. If externally we had any acid, the activity due to the H plus ions will be arrested by the basic component of the buffer. When base is added, the activity due to OH minus ions will be arrested by the acidic component. That is how buffer can maintain the pH value constant. What are the important point? Solution of weak acid, mixture of weak acid and strong base can function as a acidic buffer when NaVa is greater than NbVb, when number of milliequivalents of the acid is greater than number of milliequivalents of the base. When mixture of weak base and strong acid can function as the basic buffer when NBVB is greater than NAVA. This is one important tip. And which can act as neutral buffer, salts of solutions, salts produced due to the neutralization of weak acid and weak base. And the other important point is salt hydrolysis. So the solutions of weak acid, solutions of the salts produced from weak acid versus strong base undergo anionic hydrolysis. For them, the nature of the solution will be alkaline, pH value will be greater than 7, and pH of such salts is given by the relation 7 plus pKa plus log C by 2. What is the KH value for this? Kw by Ka. Similarly, for the salts produced from weak base and strong acid, weak base versus strong acid, this type of the salts will undergo cationic hydrolysis. pH value will be less than 7. Then what is the expression for pH? 7 minus pKb plus log C by 2. 7 minus pKb plus log C by 2. What is the other type of the salts? Salts produced from weak acid and weak base. For them, pH will be equal to 7 plus pKa minus pKb by 2. So finally, we will come to the solubility product. So we can explain the solubility product through the numericals. Now let us go to for the numericals. Question number 1. See, in a dilute solutions of acids and bases, how to calculate the OH minus ion concentration? OH minus ion concentration is equal to Kw by H plus ion concentration. In case of strong acids, H plus ion concentration is equal to normality of the acid. What is the normality of H2SO4? 0.005 into 2, 0.01, that is 10 to the power minus 2. And what will be the OH minus ion concentration? 10 to the power minus 14 by 10 to the power minus 2, which is equal to 10 to the power minus 12. Next question. At 25 degrees centigrade, the hydroxyl ion concentration of a basic solution is 6.75 into 10 to the power minus 3. Then what is the value of the Kw? When as long as temperature is maintained at 25 degrees centigrade, Kw value will remain constant at 10 to the power minus 14 irrespective of the concentration of H plus ions and OH minus ion. When a base is added, OH minus ion concentration increases. Correspondingly, H plus ion concentration decreases to keep the Kw value constant. So, Kw will remain constant at 10 to the power minus 14. Option 4 is the answer. Next question. At certain temperature, H plus ion concentration is given as 4 into 10 to the power minus 7 molar, and in pure water, as I said earlier, H plus ion concentration will be equal to OH minus ion concentration. Therefore, Kw will be equal to H plus square. 4 into 10 to the power minus 7 whole square, which is equal to 16 into 10 to the power minus 14 or 1.6 into 10 to the power minus 13. Option 3 is the answer. Next question. The number of H3O plus ions present in 10 ml of water at 25 degrees centigrade. In water at 25 degrees centigrade, H plus ion concentration is equal to H3O plus ion concentration, because in aqueous solutions solutions, free H plus ions does not exist. They will be converted into H3O plus ions, which will be equal to 10 to the power of minus 7 moles per liter. 10 to the power of minus 7 moles per liter implies 1000 ml of the water. 1000 ml of the water contains 10 to the power of minus 7 into 10 to the power of minus 7 into 6 into 10 to the power of 23 H plus ions. H plus ions, that is 6 into 10 to the power of 16. 10 ml contains how many? 10 ml contains how many? 6 into 10 to the power of 6 into 10 to the power of 14. 6 into 10 to the power of 14. Option 2 is the answer. Next question. Dissolution constant of the water at 25 degrees centigrade. Dissolution constant of the water at 25 degrees centigrade. So H2O gives rise to H plus ions and OH minus ions. H2O gives rise to H plus ions and OH minus ions. Ka is equal to H plus into OH minus, H plus into OH minus by H2O concentration. What will be the H2O, H plus ion concentrations? 10 to the power of minus 7 into 10 to the power of minus 7. And what will be the H plus ion concentration? 55.5 molar. 55.5 molar, which is equal to, which can be written as 10 to the power of minus 14 by 1000 by 18. 1000 by 18. If 18 goes to the numerator, so it is 1.8 into 10 to the power of minus 16. 55.5 molar. 55.5 molar can be written as 1000 by 18. 1000 by 18. So this is the molarity of the pure water. Molarity of the pure water. So 1.8 into 10 to the power of minus 16. Next. 1 liter of water contains 10 to the power of minus 7 moles of H plus ions. What is the degree of ionization? What is the degree of ionization? Degree of ionization, as I said earlier, alpha is equal to number of moles of H plus ions, number of moles of H plus ions by concentration of the water, initial concentration of the water. What is the number of moles of H plus ions? 10 to the power of minus 7. What is the H plus ion concentration? 55.5. That is 1000 by 18. This will be the alpha value. So there, what is the question? 100 alpha is equal to 10 to the power of minus 7 by 1000 18 into 100. Into 100. It comes around 1.8 into 10 to the power of minus 7. 1.8 into 10 to the power of minus 7. 1.8 into 10 to the power of minus 7. Option 1 is the answer. On simplifying this, we will get the answer as this. Next question. At high temperatures, what is the value of Kw? Kw is 10 to the power of minus 13. Kw value is equal to H plus square, which is equal to 10 to the power of minus 13. Therefore, H plus is equal to 10 to the power of minus 6.5. Therefore, pH is equal to 6.5. pH is equal to 6.4. Option 2 is the answer. When 100 ml of N by 10 NaOH is added to 100 ml of N by 5 HCl, the pH of the resulting solution will be greater than 7. 50 ml of N by 5 HCl. Okay, 1 second. Here, whenever acids and bases solutions are given, First we have to calculate NaVA and NBVB. What is Na? Normality of the acid. What is Va? Volume of the acid. So NaVA will be equal to number of milli equivalents of the acid. What is NaVA? What is NaVA? 1 by 5. 1 by 5. And what is the volume of the acid? 50. So it is 10. What is the NBVB value? What is the NBVB value here? 100. 1 by 10. 1 by 10 into 100. 10. Since NaVA is equal to NBVB, number of milliequivalents of the acid is equal to number of milliequivalents of the base, the solution will be neutral and pH value will be equal to 7. Option 1 is the answer. Next question. Equal volumes of two solutions with pH is equal to 3 and pH is equal to 11 are mixed. pH is equal to 3 means it is an acidic solution. It is an acidic solution. For an acidic solution, H plus ion concentration is equal to 10 to the power of minus pH is equal to normality of the acid, that is 10 to the power of minus 3. 10 to the power of minus 3. pH is equal to 11 means it is a basic solution. That implies pOH is equal to 3 and OH minus ion concentration is equal to normality of the base is equal to 10 to the power of minus pOH, which is equal to 10 to the power of minus 3. Now let us calculate NaVA value and NBVB value. What is NaVA? 10 to the power of minus 3. What is Va? 3. Here also 10 to the power of minus 3 into V. So here again NaVA is equal to NBVB. So the resulting solution will be neutral and pH value will be equal to 7. What is pH is 3 means acidic solution. pOH is equal to 11 implies it is a basic solution. pOH is equal to 3 and OH minus ion concentration is equal to 10 to the power of minus 3. So NaVA is equal to NBVB. The resulting solution will be neutral and pH value will be equal to 7. Next question. The pH of the solution is 3. This solution is diluted by 100 times. Then the pH of the resulting solution is diluted by 100 times means what is the change in H plus ion concentration? Change in H plus ion concentration. Change in H plus ion concentration is equal to 10 to the power of n. What is the n? Initial pH minus final pH. What is the change in H plus ion concentration? It is diluted by 1 by 100 and 10 to the power of 3 initial pH minus final pH. So minus 2 is equal to 3 minus final pH. So final pH is equal to 5. Final pH is equal to 5. Option 1. Next, the dissociation constant of weak acid is 10 to the power of minus 6. What is the pH of that acid? H plus ion concentration in the case of a weak acid is equal to root CKa. What is C here? 10 to the power of minus 2, 10 to the power of minus 6, 10 to the power of minus 4. So therefore pH will be equal to 4. pH will be equal to 4. Next question. Next, the pH of 0.01 molar NaCl solution is NaCl solution is NaCl does not undergo hydrolysis. This type of the salt NaCl is derived from strong acid versus strong base. This type of the salts do not undergo hydrolysis at all. So for such solutions pH will be always be equal to 7. So option 3 is the answer. Next question. The pH of the HCl is 5. It is diluted by 1000 times. Its pH will be as I said earlier, for solutions of for in case of strong acids and strong bases, for very dilute solutions of strong acids and strong bases, pH value will be nearly equal to this 7. If it is an acid, it will be slightly less than 7. If it is a base, it is slightly greater than 7, because here pH of the HCl is 5. It is diluted by 1000 times. Then what will happen to the final H plus ion concentration due to the acid? It will be 10 to the power of minus 8. It will be 10 to the power of minus 8. What is the initial H plus ion concentration? 10 to the power of minus 5. After diluting by 1000 times, its H plus ion concentration will be 10 to the power of minus 8. Then what will be the H plus ion concentration total H plus ions due to the acid plus H plus ions due to the water, H plus ions due to the water. What is the H plus ions due to the HCl? 10 to the power of minus 8. What is H plus ions due to the water? 10 to the power of minus 7. Because this is a very dilute solution, the ionization of the water cannot be suppressed here, because common ion effect is very weak due to the low concentration of the acid. So total H plus ion concentration is equal to 10 to the power of minus 8 plus 10 to the power of minus 7. If you simplify that, we will get the answer near to the 7, that is 6.7. It must be around 6.96. Next, the pH of a solution is 6. Here what happened here? The H3O plus ion concentration, that is H plus ion concentration, is decreased by 1000 times. So H plus ion concentration in the initial solution, H plus ion concentration is 10 to the power of minus 6. The H plus ion concentration is diluted by 1000 times. So in the dilute solution, H plus ion concentration will be 10 to the power of minus 9. Therefore, pH is equal to 9. By some mechanism, they have seen that the H plus ion concentration is diluted by 1000 times. So ultimately the pH value is 9. In the previous example, they have mentioned that acid is given. For an acid, however how many times we have got diluted, it will remain as an acid only. That is why its pH value is below 7. In this case, they have specifically given that the H3O plus ion concentration is diluted by 1000 times. Therefore, pH will become 9. Next question. The pH of a solution is 3.602. Its H plus ion concentration is, you whenever remember pH is equal to x point y, then H plus ion concentration will be equal to 10 to the power of minus x plus 1 into antilog of 1 minus 0.y. 1 minus 0.y. This is a shortcut formula to find the H plus ion concentration when the pH value is given. In this case, what is the pH value? 3.602. 3.602. So in place of x we have 3. In place of y we got 0.602. 0.602. Now what is the H plus ion concentration? 10 to the power of minus 3 plus 1 and antilog of 1 minus 0.602, that is around 0.399. For antilog of 0.4 will be around 2.5. So 2.5 into 10 to the power of minus 4. 2.5 into 10 to the power of minus 4. This is a simple way to arrive at the answer at a quicker time. 2.5 into 10 to the power of minus 4. Option 3 is the answer. Next. the pH of the solution is 9. It is how many times more basic than the solution with the pH is equal to 6. Obviously it is 1000 times. pH is equal to 6 implies pH is equal to 9 implies pOH will be equal to 5 and OH minus on concentration will be 10 to the power minus 5. In pH is equal to 6, here pOH will be equal to 8 and OH minus on concentration is 10 to the power minus 8. Therefore, while comparing the OH minus on concentration 1000 times. So, solution of pH value 9 is 1000 times more basic than the solution of pH value 6. Next question. The pH of a solution is 11. It is diluted by 1000 times. Then pH of the resulting solution is pH is equal to 11 implies it is a basic solution. So, when it is diluted, which OH minus on concentration gets diluted. What is the pOH value? What is pOH value? 3. What is the pOH value? 3. When it is that is OH minus on concentration is 10 to the power minus 3. When it is diluted by 1000 times, OH minus on concentration becomes 10 to the power minus 6. So, OH minus on concentration becomes 10 to the power minus 6. pOH will be equal to 6 and pH will be equal to 8. pH will be equal to 8. Option 1 is the answer. Next question. The pH of a dibasic acid is 3.699. The pH of a dibasic acid is 3.699. So, it is a dibasic acid. So, H plus on concentration is equal to normality of the acid. What will be the molarity of the acid? Molarity of the acid is equal to normality of the acid by 2, because normality is equal to molarity into basicity. Therefore, molarity is equal to normality by basicity. Let us find normality of the acid, that is H plus on concentration is equal to, as discussed in the previous problem, H plus on concentration will be equal to 10 to the power minus 3 plus 1 into anti-log of 1 minus 0.699. So, it will be 0.3, anti-log of 0.3 is 2. So, H plus on concentration, that is normality of the acid, is equal to 2 into 10 to the power minus 4, and what will be the molarity? 1 into 10 to the power minus 4. 1 into 10 to the power minus 4. Option 4 is the answer. Next question. This is a case of buffer solution. This is a basic buffer solution. pH is equal to 9.25. pH is equal to 9.25 implies pH is equal to 9.25 implies pOH will be equal to 4.75. 4.75. For basic buffer, what is the expression we have? pOH is equal to pKb plus log salt concentration by base concentration. Salt concentration by base concentration. Since salt concentration and base concentrations are equal, pOH will be equal to pKb is equal to 4.75, because this term will become 0, because salt concentration is equal to base concentration. This term will become 0. Then pOH is equal to pKb, which is equal to 4.75. Option 2 is the answer. Next question. The pH of an aqueous solution of NH4CN is, so how do you get NH4CN? NH4CN is the salt of, NH4CN is the salt of weak acid. It is generated from a weak acid and a weak base. It is generated from a weak acid and a weak base. For it, pH is equal to 7 plus pKa minus pKb by 2. pKa minus pKb by 2. pKa minus pKb by 2. What is the pKa value? What is the pKa value? Ka value is 9.2 into 10 to the power minus 10. Ka value is equal to pKa is equal to minus log 9.2 into 10 to the power minus 10. 9.2 into 10 to the power minus 10. So 10 minus log 9.2. 10 minus log 9.2. It must be 0.98. So it is around 9.02. pKa is approximately 9.02. What is the pKb value? What is the pKb value? Minus log 1.8 into 10 to the power minus 5. It is 4.76. It is 4.76. 4.76 pKb value. Substituting in this, 7 plus pH is equal to 7 plus 9.02 minus 4.76 by 2. Certainly it is greater than 7. We need not do all this calculation. Because in the question they did not specifically ask the pH value. So for academic sake we have derived that. But what is the small hint there? Since Ka value is less than the Kb value, it is a salt derived from a weak acid and a weak base. And what is the hint to be noted there? Ka value is less than Kb value. Obviously the resulting solution will be alkaline. When Ka value is less than Kb value, the solution will be alkaline. For an alkaline solution, pH value will be greater than 7. So just we have derived it. That's it. So it will be greater than 7 because Ka value is less than Kb value. Next. Now coming to the solubility product. The molar solubility of PbI2 in presence of 0.2 molar lead nitrate solution in terms of solubility product is. Now what is the expression for PbI2? For any general salt AXBY, for general salt of AXBY type, KSP will be equal to x to the power of x, y to the power of y, s to the power of x plus y. For PbI2, what is the expression? PbI2 gives us to Pb plus 2 plus 2i minus. When S moles of PbI2 dissolves, we get S moles of Pb plus 2 and 2s moles of I minus. Now there is another salt is there, PbNO3 taken twice. It is a strong electrolyte. So it ionizes completely. 0.2 molar will give rise to 0.2 moles of Pb plus 2 and 2NO3 minus. Now what will be the Pb plus 2? What is the expression for Ksp? Ksp is equal to Pb plus 2 concentration, Pb plus 2 concentration into SO4 minus 2 I minus concentration. Ksp is equal to Pb plus 2 concentration minus I minus concentration. What will be the Pb plus 2 concentration? What is the Pb plus 2 concentration? Pb plus 2 concentration is equal to S from the PbI2 and 0.2 from the PbNO3 taken twice, which can be taken as 0.2. Which can be taken as a 0.2. And what is I minus concentration? 2S. So Ksp is equal to 0.2 and what is I minus concentration? 2S whole square. Now we have to calculate the S value. So Ksp is equal to 4s square into 0.2. 4s square into 0.2. S square is equal to Ksp by 0.8 and S is equal to root of Ksp by 0.8. Option 3 is the answer. The solubility product of rare earth metal hydroxide is at a room temperature is, its solubility product value is given as 4.32 into 10 to the power minus 14. For MOH taken thrice, what is the expression for Ksp? Ksp will be equal to x to the power of 1 and 3 cube into s to the power of 1 plus 3, that is 27 s to the power of 4. 27 s to the power of 4 is equal to, we can write it as 432 into 10 to the power of minus 16. So s to the power of 4 is equal to 432 by 27 into 10 to the power of minus 16. Solving S will be equal to 2 into 10 to the power of minus 4. 432 by 27, 270. It must be around 16 times. 16 times. So 16 into 10 to the power of minus 4 minus 16. Therefore S is equal to 2 into 10 to the power of, which is equal to 16 into 10 to the power of minus 16. Okay. Next, the solubility of PbSO4 in 0.01 molar Na2SO4 solution is, so this is also same as in the previous example. This is also finding the solubility in presence of a common ion, So PbSO4 ionizes as Pb plus 2 SO4 minus 2. What is the concentration here? S and S. When in presence of Na2SO4 0.01 molar, 2Na plus SO4 minus 2, 0.01 molar. So Pb plus 2 concentration is equal to S and SO4 minus 2 concentration is equal to S plus 0.01, which can be written as 0.01. Now Ksp is equal to, Ksp of lead sulfate is equal to S into 10 to the power of minus 2 is equal to 1.25 into 10 to the power of minus 9. 1.25 into 10 to the power of minus 9. So S will be equal to 1.25 into 10 to the power of minus 7. 1.25 into 10 to the power of minus 7. Option 1, it is wrongly printed. 1.25 into 10 to the power of minus 7. 1.25 into 10 to the power of minus 7. Next. The KSP of the salt having the general formula mx2 is 4 into 10 to the power of minus 2. What is the concentration of the m plus 2? So mx2 ionizes into m plus 2x minus. So its solubility is S, 2S. So what is the finding the concentration of m plus ion is nothing but finding the concentration of the solubility. So KSP is equal to S into 2S whole square is equal to 4 into 10 to the power of minus 12. 4 into 10 to the power of minus 12. 4S cube is equal to 4 into 10 to the power of minus 12. S cube is equal to 10 to the power of minus 12. S is equal to 10 to the power of minus 4. So 10 to the power of minus 4. So S is what is the concentration of m plus? Yes, S value is 10 to the power of minus 4. Option 2 is the answer. Next, the solubility product of BaSO4 at 18 degrees in 1.5 into 10 to the power of minus 9. Its solubility at the same temperature. What is the expression for the solubility product of barium sulfate? S square. What is the solubility for the product for barium sulfate? Barium sulfate ionizes into Ba plus 2 and SO4 minus 2. So its solubility is S and S. S square is equal to 1.5 into 10 to the power of minus 9, which can be written as 15 into 10 to the power of minus 10. So S is equal to square root of 15 into 10 to the power of minus 5. Square root of 15 is around 3.9 something. So S is equal to 3.9 into 10 to the power of minus 4. Option 4 is the answer. Next, the solubility of AgCl in 0.1 molar NaCl is. So this is also an example for finding the solubility in presence of common ion. So KSP of AgCl is equal to Ag plus Cl minus. What is the Ag plus ion concentration? S. What is the Cl minus ion concentration? S plus 0.1. Which is equal to 1.2 into 10 to the power of minus 10. 1.2 into 10 to the power of minus 10. S plus 0.1 can be written as S into 10 to the power of minus 1 is equal to 1.2 into 10 to the power of minus 10. S is equal to 1.2 into 10 to the power of minus 9. 1.2 into 10 to the power of minus 9. Option 4 is the answer. Next, the solubility product is 1 into 10 to the power of minus 10. Then what is the pH of its aqueous solution? Since the given salt is a base, so we get first pOH. From pOH we can get the pH value. What is the MOH? What is the KSP expression for that? M plus into OH minus, which is equal to S into S is equal to how much? Is equal to 1 into 10 to the power of minus 10. 1 into 10 to the power of minus 10. So OH minus ion concentration is equal to S is equal to 10 to the power minus 5. POH is equal to 5. pH is equal to 9. So for a base, how do you get pH value? 14 minus POH. Next question. What is the concentration of Cn minus ions in a solution with 0.1 molar HCl and 0.01 molar HCN? Here there are two HCl ionizes completely, H plus and Cl minus, H plus and Cl minus. What is the H plus ion concentration? 0.1, 0.1. HCN ionizes partially, H plus and Cn minus. What is applying Ka? Ka is equal to H plus into Cn minus by HCN. By HCN. Here this is X and X. X and X. But what can be the H plus ion concentration? X plus 0.1. X plus 0.1. Why X plus 0.1? X is from HCN and 0.1 from H plus ion. This is a case of simultaneous equilibria. So H plus ion concentration is X plus 0.1. And since Ka value, Ka is equal, what is the Ka value? 10 to the power of HCN is, Ka value is 10 to the power minus 6. 10 to the power minus 6. What is H plus ion concentration? We can straightway write as 0.1 into X. What is the HCN concentration? 0.01. 0.01. 0.01. So 10 to the power minus 2. 10. What is the value? 1 by, this is 10. 10. So X is equal to 10 to the power minus 5. Cn minus ion concentration is 10 to the power minus 5 or 10 to the power minus 7. Once again, this is 10. When it comes to the X is equal to 10 to the power minus 6 by 10, this is equal to 10 to the power minus 7. We can neglect the ionization of the HCN will be suppressed due to the common ion effect. Therefore, H plus ion concentration will be taken as 0.1, and since the ionization of HCN is completely suppressed, the concentration of HCN at equilibrium will be equal to the initial concentration. That is why it is taken as 0.01. This is nothing but an application of the common ion effect. What is the common ion effect? A consequence of the common ion effect, the ionization of the weak electrolytes will be suppressed in presence of a common ion. Next, how many grams of NaOH can neutralize 100 ml of H2SO4 solution with a pH value of 3.3? What is the bond here? Number of equivalents of NaOH, number of equivalents of NaOH is equal to number of equivalents of H2SO4. Number of equivalents of H2SO4. Here, how do you get it? Weight by equivalent weight, weight by 40 into normality into volume in ml by 1000. Normality into volume in ml by 1000. For H2SO4, what is the volume? 100 ml. For 100 ml, normality of the acid is equal to 10 to the power minus pH, 10 to the power minus pH, that is 10 to the power minus 3.301, which can be written as 5 into 10 to the power minus 4, 5 into 10 to the power minus 4. Now W by 40 is equal to 5 into 10 to the power minus 4 into 100 by 1000. So solving it, we will get the weight of the NaOH. Thank you. We will continue in the next class.